Troubleshooting switch virtual interfaces and routed ports. VLANs without routing is like cookies without milk. Eventually you just kind of choke. VLANs are awesome to be able to segment your network into different groups and security boundaries, but eventually you're going to want to get that traffic off the VLAN and either to another VLAN, maybe you've got a server VLAN up here with critical resources, or off to the internet to get whatever resources you're accessing out there. The small business solution is the router on a stick, and a lot of people may laugh at it, but I have used this solution time and time again. It's a standby. I've been in networks that even are a little beyond a small business, and they deploy voice over IP and realize, oh no, we can't upgrade to a layer 3 switch infrastructure, it's outside of our budget. So I'm like, hey, you know what, quick and dirty, let's get a router on a stick going, because with a voice over IP VLAN, you got IP phones, they're not really accessing the data segment too often. You're not going to overwhelm your router. Let's do this. So the way that you set up a router on a stick is you configure a trunk port from your Cisco switch, or a truck, whatever configuration you'd like, a truck port from your Cisco switch into your Cisco router or firewall. There's a lot of different devices that can do this. The router you actually divide into sub interfaces. So instead of just having fast Ethernet or gigabit Ethernet 0/0, you essentially have no IP address on that guy and then have fast Ethernet 0/0.10. Maybe this is VLAN 10 that you're routing for. It doesn't have to match, but by golly, why would you not do that? And then you assign an IP address on there from VLAN 10, and then the key word is you go under it and do encapsulation.1q10, which tells that sub interface, is obviously abbreviated, to respond for VLAN 10 traffic. And then you do the same thing for VLAN 20, and now you've got a router on a stick. The big advantage of this is right here. Simple to set up, lower cost. You don't have to buy a layer 3 switch infrastructure. The disadvantage is that, number one, this is a congested link. You've got traffic going in and out on that link constantly. You kind of have this corn dog effect. Most of the time it's going off to the internet, which is great, but when you start going between different VLANs, it can become a bottleneck. It becomes a single point of failure. Now you can help circumvent that using a first hop routing protocol like HSRP or VRRP or something like that, but usually you're doing this because budgets are limited and routers on a stick aren't cheap. Delay in routing, meaning you have some delay going out of the switch into the router and then back out, and the router is all software based, so there's no ASICs to help you out. And that's what paves the road for the enterprise solution, layer 3 switching. Very happy to report to you that layer 3 switches have come down drastically in price. And I would say not only come down in price, but it's becoming a mainstream feature to where even, consumer grade switches a lot of times will include layer 3 switching. The Cisco small business line, HP kind of, small business switches, they all have layer 3 capabilities built into them, which is awesome because it helps us optimize our network environments when budgets are really slim. So a couple ways this can go down. You can go onto the switch itself and create your VLANs. You got VLAN 10, VLAN 20, but then you go into global configuration mode and type in interface VLAN 10. Give it an IP address, and you've just created yourself a switch virtual interface, which is this invisible, I always draw them like little kind of staffs coming out of here, and I say 10.1.10.1 because it's an invisible interface. You won't actually see it in the switch, but whenever somebody is assigned to the VLAN 10 VLAN, there's a better way to say that. Whenever a port, how about that? Whenever a port is assigned to VLAN 10, it has the ability to access that SVI, which is typically their default gateway. So let's just say this guy is deciding to go to the internet. He goes and pings 8.8.8.8 to get a response. That's going to come to the router inside of that switch, and it's going to say, oh, let me look at the routing table, 8.8.8.8. Well, let me see that. Well, oh, it hits my default route, which says 0.0.0.0/0 goes to, and that's where our second capability of a layer 3 switch can come in, a routed interface. You go under any interface on a layer 3 switch and type in no switch port, and you end up converting that thing into a routed interface. Now I can come into Fast Ethernet 2/24, give it an IP address, 10.1.24.1, 255.255.255.252, and that thing now has an IP address on that interface, which acts just like a routed port. Jack that thing right into Fast Ethernet 0/0 or Gigabit Ethernet 0/0 on this router. I don't know why I always feel like I have to say Gigabit Ethernet, because otherwise people are like, man, that guy's old. He's talking about fast. I don't know why. It's just so every time I'm like, oh, I can't say Fast Ethernet anymore because I'm old. So anyway, that too. So we can set the default route to point to that .2 interface, and this guy can then set up our NAT and route us out to the internet and all that kind of stuff. Now, a lot of times these layer 3 switches are not doing that because they are ASIC based. Their greatest power is their greatest weakness. ASIC based means you got routing going on at wire speed. You got the backplane of bandwidth available to you, to where instead of having that router on a 6 slow down bottleneck point, it's like fast. No, it's like gigabit, not fast. And it's going between all these different things, super speed. So then you can also enable redundancy to where you have a couple of these switches, HSRP going on between them. So it's huge advantages, but because you've got these ASIC based switches, actually I didn't even put that as a disadvantage. We'll just say feature limited, right? Because it doesn't have all of the same features that a software-based or iOS-based router can have. Now, this does have the iOS, but again, anything it can't do in the ASIC becomes a major bottleneck. So what could possibly go wrong with router on a stick or layer 3 switches? Plenty. First off, there's 2 nuggets already in the T-Shoot series that deal with VLAN and trunk misconfiguration, and all those topics apply right here. If you've got a layer 3 switch connected to another one with some devices hanging off, that's a trunk port, my friend. And that needs to make sure we've got the encapsulation set on both sides, dynamic trunking protocols negotiating, you've got the VLANs added on both sides, you've got the switch port trunk allowed VLAN configured identically on both sides of this link. So all of that stuff that we talked about back then applies right here. In addition to that, we have to think about the IP address assignment. The switch virtual interface is part of that VLAN. So VLAN 10 has a specific subnet. The devices inside of there should match whatever subnet you've assigned to this, as well as ensuring that the SVI is correct. Now, again, always, whenever you see these little things, I know, and if I was just, I was just thinking as I was looking at this, I'm like, well, duh. Like, of course, your IP address has to be configured correctly, but always step back to a bigger picture where you're looking at a topology that looks like this with all these devices and this, and you've got a switch over here and this connected over here, and and what I'm talking about is the T-Shoot exam. And you're sitting there like this. The symptom is this guy's not getting an IP address via DHCP, and they're like, fix that and make sure that it can ping the other side. Well, you're uncovering all kinds of things in this whole map. You're like, okay, let me click on this switch right here, which is one of 50 devices. Do we have the right VLAN on there? Yeah, is that correct? Is the trunk going from that device? Again, when we're talking about it in bullet list format, it's very different than when you're actually looking at a big old scenario where you're trying to pull that one element, that incorrect IP address assignment, out of there. So when you see this, I mean, obviously say, well, of course that has to be, but that's one of the things on your checklist as you go through and verify end-to-end connectivity for your devices. VLAN not created or SVI shut down. Let me show you what that looks like. I'm going to bring up a switch right here, layer 3 switch. Show IP interface brief. I think it has an IP address right now, which is part of the VLAN 1. But let's just say we go in and do interface VLAN 70. I am sure I don't have that. IP address, we'll do 10.1.70.1. throw a class C subnet mask on there and back out. Now I'm going to do a show VLAN, and you can see on here there is no VLAN 70. There's a 50, no 70. So when I do a show IP interface brief, what do I see? I see this interface right here, VLAN 70, which is currently, depending on your iOS version, some of them will be administratively down until you shut them down. This one, it just comes up, well, it comes up as down, if that makes sense. So the status is down, the protocol are down. Now that tells us essentially when we see a status is down, think of physical layer, nothing's going on. So we first need to create the VLAN. So go in there and do a VLAN. We'll come back to that. So go in there and do a VLAN 70 and create the VLAN, and also make sure that you don't have the administratively down state on that interface. SVI inactive. Let's just see if we are. Everything's falling apart. There we go. No, we're still hanging out on our domain name resolution. SVI inactive is a big one. This interface will stay inactive even though the VLAN is created. Let me pause. Hang on. There we go. Okay, let's go in there. Just do this before I forget. No IP domain lookup. Turn off that lovely feature. So I'm going to create, what did I say, VLAN 73? 70. VLAN 70. So we now have a quote-unquote VLAN that matches up to it, but if I go back and do a show IP interface brief, I'm still going to see that that interface is down. Now notice, this is what I'm talking about with inactive. Now that the VLAN is created, it comes up. Okay, good. Physically, I'm feeling a little more warm and fuzzy. Why is it down? Well, that's because there's no active ports assigned to that VLAN 70 that I just created. So physically it's there, that's why I see the first up, but essentially there's nothing assigned to it. Let me do a quick show interface trunk. I want to see if I have any. No, I don't. I'm looking down at my switch right here. Show, I can't see it. Show spanning tree. There we go. Okay, so fast Ethernet 2/0/2 is a root port. So I'm going to go into that guy and do interface fast Ethernet 2/0/2. That again, root port spanning tree wise just tells it that's the way it's going to reach the root bridge. You can see all those other ports are blocked. I have a little myriad of switch ports that are connected to another switch. One of them is active. So I'll say switch port mode trunk. Actually, that's not going to take that. Yep. Switch port trunk encapsulation .1q. Hit the up arrow. I've got it as a trunk, which now is sending all VLANs. And it says, okay, change state to down. Now it's up. And what I would expect to see in just a moment. Ooh. This may not play into it. 2/0/2 interface fast Ethernet 2. This may not play into it, but I'm going to do switch port trunk non-negotiate. Non-negotiate. What? Oh, wait a sec. Switch port no negotiate. There we go. That turns off the dynamic trunking protocol, which I just want to say, you know what? It is a hard-coded trunk. Don't try and negotiate with the other side. Just do your thing. Now it's going to, and see when dynamic trunking protocol, it's trying to identify which VLANs are active. Now take a look. It's like, oh, okay. Now interface VLAN 70 is changed up. I'll do that show IP interface brief. I should see up, and I do, because that VLAN 70 has been added to the trunk port. Right? It's now active within that trunk interface, so the VLAN interface, or the SVI, comes online. There's a ton of troubleshooting that you'll go through on that, because you'll be on the exam or you'll be in the real world. You're like, why is that thing down? Why is it down? That's the two things. One is the VLAN isn't created, or you don't have any active ports in that VLAN. Now, I created a trunk just because I felt like it right then, but you could also take an active port and just assign it to VLAN 70, and then that'll also make the port active. Last thing is the no switch port command not entered, and that's the routed port. I was reaching on this one. See, a routed port is where you literally, and I mentioned this just a moment ago, you go into the interface. I'll do fast Ethernet 2/0/1 and do a no switch port. And I'm like, what's wrong with that? I mean, it's essentially at that point when you do that, it now can be assigned an IP address 10.1.1.50 or 62 255.255.255.255.0, right? It's now a routed interface. So when you're troubleshooting routed ports, it's like, okay, maybe you didn't type that command, but then even as I was thinking that, I'm like, but then you wouldn't be able to assign an IP address. So think about that, but then combine it with this. Like maybe the other side is messed up in some way. It doesn't have the right IP address, doesn't have the right subnet. Something's going on the other side, but really, a routed interface, there's not too much you can do wrong. You now understand the areas to check for SVIs and routed ports. I hope this has been informative for you, and I'd like to thank you for viewing.